So, hello everyone. My name is Alex. We'll be talking with you about agents today, and I work for the company which essentially develops AI agents to use in your IDE. And in the company, my main responsibilities are I'm head of ML and DevOps, but I also double as DevRel, Dev Ask Me Anything. So pretty much as you would expect in a startup, I do a lot of things. And yeah, I work as an encoder. And as part of my DevRel responsibilities, I attend a lot of conferences, of course, and I talk on them. And on a lot of conferences lately, you've been bombarded by AI talks. And I hope you don't feel like this, right? When you come to a conference and like half of the conferences, if not more, are about AI and how you can use it in your everyday life, in your coding, in your planning your everyday life and whatnot. So hopefully, since you're here, I hope you don't feel like that. But if you do, sorry. But yeah, and it's not just conferences. If you go to if you go online, if you go to any news website, you can see headlines like this that AI will soon replace developers. In this case, it is supposed to be an army of junior engineers or virtual junior engineers, or even Mark Zuckerberg recently said that mid-level engineers will soon be replaced by AI. And usually during the talks on the conference, you hear how you can use AI. But today we will actually be talking about how you can actually build AI that will replace you. And oh, maybe not. We'll see how it goes. But yeah, without any further ado, so the main focus of our today's talk is AI agents. And AI agent in general can be defined as a software that performs tasks on behalf of the user. And throughout the talk, I will be interchangeably use terms coding agent and AI agent, just because all the things which I will be talking about today and which I will be showing today are applicable to AI agents in general. But because I'm specifically talking about coding agents, my examples would be about coding. But in general, as I said, for the purpose of agents in general, all the things which I will be showing are applicable to agents in general. Now, with this definition, you might say that, well, I mean, any software performs the tasks on behalf of the user, right? Even the existing coding assistants, like GitHub Copilot, you can ask it to generate the code, and it is essentially performing the task on the behalf of you as a user, right? And you can ask it to generate millions lines of code or 10,000 lines of code, and then spend time debugging it or trying to make it work. Now, the difference with the agents is that they follow several agentic design patterns or principles. First one being tool use. So agents can not just generate the code, they can also use any tools like web browser, or they can run the code, so they can use Bash, for example, or any tool at their disposal. The second part is planning. So they can also do some planning steps, pretty much like we do as humans, right? They can create a sort of, I guess, step-by-step plan and then execute it. They can also reflect on each other or on their own work. So you can have multiple agents critiquing each other, coming up with a plan on how to proceed and so on. And well, as sort of already mentioned, they can also collaborate with each other, so they can critique each other, they can help each other. So one agent can delegate the task to another agent, pretty much like you would do in the real life world. Right? And you can think of agent sort of like a vacuum cleaner, like Roomba or whatever. Or in this case, OpenAI decided to call it iRobot, I guess. But in general, the software which runs on the robot vacuum cleaner is essentially an AI agent, right? And its task is to clean your house, but without the tool use, but which OpenAI actually quite aggressively highlighted. Without brushes, for example, it can't do its work, right? It can also do its work. Well, it can do its work without planning the route. And again, for some reason, OpenAI thinks that robot vacuum cleaners walk in this weird maze. But in general, robot vacuum cleaners try to optimize their path. So they try to plan ahead what kind of pathway they need to take to get to do a better job. They still can't collaborate with each other. I think, but I mean, I'm sure that soon any household appliance will be able to talk to each other, and we will get to the multi-agent collaboration as well. So, yeah, basically, that's a good example of agent in real life world. Now, let's get from agents for a second and talk about us, developers, right? So what do you think developers spend their time most on? And it's not coffee, you know. So any ideas, any thoughts on what we spend time on? Yeah. Waiting, okay. Reading code, okay. Yeah. Sorry? Okay. That's a good one. Okay. Well, I mean, all of those actually can be, I guess, labeled as understanding, right? So you need to understand the code to give a good variable name. You need to understand the code to be able to read it. You need to understand, well, the requirements from the client. Hopefully, they are understandable. And actually, if we look at the actual, distribution of the time, and this research was done in 2015, so 10 years ago, but I don't think much has changed really. So 70% of the time, developers focused on understanding, and only 5% were spent on editing the code. So, if we sort of want AI to be able to help us, if we want agents to help us, we don't need them to just we don't need them to just edit code, right? And if you actually think about patterns, which I just mentioned, and overlap the patterns with this diagram, we will be able to see that actually we have tool use, first of all, right? So for tool use, we can use IDEs, we can use browsers, debuggers, whatnot, right? We also have planning, of course, and for planning, we need to understand. We need to probably, spend some time outside of IDE. We need to navigate and so on. We need to reflect, of course, and reflection is mainly based on our understanding. And then, of course, we have multi-agent collaboration, which, again, based on, in huge part, on understanding, right? So basically, all of the agentic patterns, which you can find in any AI agent, can be reflected in our everyday life. So basically, in our everyday life as a coder, we essentially act, in a sense, as an AI agent, right? Because we have tools, we can do planning, and so on. So basically, if we want to have a good AI assistant, or if we want AI to replace us, maybe in the future, who knows, we essentially need to be able to tell AI to have all those steps, right? So it needs to do planning, it needs to reflect, use tools, and so on. Now with that, let's actually see in action how we can make AI do all of that. And all of the code is available on this QR code or on this GitHub repository. If you want to play around with it after the call, after the talk. Yeah, and the way I structure the live coding part of the presentation is I like to start with something basic, like with a baseline. Then we will go through several stages, and hopefully not these stages. Yeah, we will go through several stages from some baseline where we'll just ask OpenAI to do something for us, and we will gradually build on top of that to get to the multi-agent collaboration where they will be building a website for us. So with that, let me switch to the Jupyter notebook. Oh, come on. Okay. It doesn't want me to show you anything. Okay, so let me zoom in a bit. Hopefully you can see. Okay, all right. So all of the code I will be showing is in Python, but you don't need to have a Python knowledge to be able to read it. It's pretty straightforward, and in this specific case, it is pretty typical way to call the LLM. In this case, OpenAI GPT-4. So basically, just sending a request to the model, and if you played around with the LLM, and I hope you do, I hope you use AI in your everyday life. If you did a similar exercise in your spare time, you probably would get the similar experience that OpenAI or Anthropic, Claude, for that matter, they don't have access to your local machine by default. They don't have access to internet and so on. So basically, they are useless outside of what they already learned from the data, right? So if the internet allows me to do that, we can ask the model to, well, get the response time for Google, right? And it won't be able to do that because, well, it doesn't have access to internet, right? We can also try to ask what Python packages I have installed. And again, it will fail just because it doesn't have access to my local machine, right? And the same goes with the Python 3.14, and hopefully it will answer us something. Let's see if the internet will collaborate with us today. No, maybe not. But yeah, well, basically, again, it would be pretty much the same answer. Okay, finally. So yeah, it indeed doesn't have capability to have direct access to my local machine, which is expected, right? It did provide some bash commands to at least be somewhat helpful, but it's not really helpful in real life world, right? We won't be copy pasting a bunch of bash commands and just running them. And the same goes with the newest knowledge. So in this case, Python 3.14, I think it's not yet released. And still, because the model was updated last in 2023, I don't think it will know anything about even Python 3.12 or 3.13. So of course, it doesn't even know anything about new versions as well. So how we can fix that? Well, we can go to the tool use, right? So let me go through the basic agent. So we will be using ChatGPT once more. Now in this case, we will actually first instruct it to not just generate the answer, but also do some sort of planning step, some sort of thinking step. And we will achieve that through what is called a React framework. And React stands for reason and act. So let me quickly go to the prompt. So basically, what React framework means is that we will instruct LLM to go through a loop of 5 steps. So the first one is thought. So the LLM would need to think about the next step it needs to take to give us the answer. It will then need to decide on the action it needs to perform to be able to, well, achieve that, fulfill that request, that thought. Then there is a pause step where a LLM will wait for the action to actually be executed. There is observation step where LLM will get the output from the action and then, well, observe the output and decide what to do next. And then, depending if it got enough information or not, it will give us the answer. Or if there is not enough information, it will go through the same loop once more and until it gets to the answer. And you can pretty easily implement this through this prompt. So you just need those 5 lines essentially. Which just describe what I just told you, right? So you are running in a loop of thought, action, pause, observation. Think about it, choose action, and so on. And in this case, we also provide the LLM with several actions. So in this case, we will have actions like ping, which would allow it to ping any website, and we provide the example on how to use it. So it would need to say ping, semicolon, and then the website. And there is also a description for the command itself. There is bash command, which would allow LLM to run any bash command. And there is web search, which would allow to do any web search. So we also provide some example session for the LLM. So ideally, if everything goes well, we should see the following process. So the question is the input from us, from the user. So it's basically our query. So in this case, we would ask how many islands make up Madeira. And I live on Madeira, so that's quick shout out to that beautiful island. Then ideally the LLM should think, okay, so I have the question, I need to do web search about Madeira. It will need to specify that it wants the action, web search, and then the actual search request. Then the pause step is where we run the action. Then observation is hopefully a proper one, a proper web research result. And then the output, again, hopefully will be the correct one. So let's see how that will work in action. Again, we are querying the model in pretty much the same way as you would do before. And here we have our 3 tools or actions, which we defined before. So we have ping, we have bash, and we have web search. They are pretty straightforward, nothing fancy here. So let's test them out. Ping, bash, and web search. So ping works, bash works, and web search also gave us a bunch of text about Python 3.14. Okay, all good. So here's just a helper dictionary of known actions, and this is where we basically implement the actual loop for the LLM. So we will run the query first with our input message from the user. Then we will see if LLM decides to do any action, to call any action through this action semicolon sort of pattern. If there is an action, we will run it, give the output to LLM, and then LLM decides what it wants to do next. If it has enough information for that to give us answer, or if it needs to go through another loop of React framework, basically. So we will also limit it to 5, just to avoid any infinite loops. But let's see how the same questions will work now for our LLM. So the response time for Google, okay, decided to call the ping command, right, which seems correct. It got us, well, we did run the ping locally, and the LLM gave us answer. The same goes with the Python package. Hopefully, it will want to execute the proper command. So in this case, it is piplist. So running piplist locally gave us a bunch of packages, and yeah, so in this case, LLM decided to just count them, I guess. Not very helpful, but well, it is what it is. And the same goes with the web search. Hopefully, it will use the web search. So yeah, it decided to do the web search for what's new in Python 3.14. And somewhere after all this text, it should give us the summary, hopefully, from the... Yeah, so here's our answer from LLM. Right, so this is sort of a quick summary of what is new in Python 3.14 according to the web search which LLM just did for us. And it is pretty straightforward to define all those tools, right? But of course, those are just simple examples, and you probably don't want to spend time on defining, the same code, the same functions for Jira integration, right? You don't want to spend time on giving LLM access to Sentry or whatever, right? Because it's a lot of API calls, it's a lot of boilerplate code, which hopefully someone already written for you, and you can leverage that. And that is indeed the case. And for that, we will actually use what is called MCP protocol. So let me quickly get back to the slides. So MCP protocol, where MCP stands for Model Context Protocol, is basically a thing that allows LLMs to get information about any tools available at its disposal, and then through the protocol interact with those tools. So what we have in the MCP is basically we have MCP client or MCP host, which can be either cloud, like Cloud Desktop, for example. It can be your IDE with any agent installed. It can be some CLI tool. It doesn't matter. It just needs to be some sort of MCP client. And then through MCP protocol, it can interact with MCP servers, which basically just a set of tools defined to interact with either some local resources. They can also interact with any web-based resources like API and whatnot. So Jira, for example, again, or just running bash commands also can also be MCP server. And you can pretty quickly and easily define your own MCP servers as well through the special framework designed by Anthropic. So let me go to the third stage of our path to multi-agent collaboration. So over here, I have a simple MCP server. Again, I'm doing the bash tool, basically. But Anthropic nicely provided this sort of wrapper or syntactic sugar for our MCP, which allows us to quite quickly define our own MCP tools through this header over here. And again, for the bash tool, it is pretty straightforward. We just run the bash command, whatever is passed and on to the function. And don't do that in real life, of course. But yeah, basically, this will allow LLM to interact with our MCP server. Now let's actually see that in action now. And you can define MCP servers for MCP client to use through the JSON format, through the JSON file, which is pretty straightforward. So you just define the name of the tool, the name of the server, command to run, and its arguments. So in this case, it will be Python, and then the name of the file. But in general, it can be whatever you want. It can be npx npx library, it can be Docker image, and so on. So basically, whatever you want, whatever you are able to run locally, you can define here as well. And here is another example of more tools. So in this case, I have a file system tool, which is run as npx package, and it gives access to your local file system. We also have the Brave search, so it's basically a search engine which is running inside the Docker. We also have fetch, which will allow us to fetch any URL, and it's Python command. And we have our bash tool, which is also a Python command. So let's actually see that in action. And what I will be using here is essentially an MCP client, again, from the Anthropic's MCP package. There is some boilerplate, but otherwise it is, again, pretty straightforward. You just define the main thing you need to define is the way to connect to servers, which essentially just reads the config from the JSON and then connects to the servers, getting all the tools available to use for LLM. And then we also have the query over here, where basically, as part of the query, as part of the input to the LLM, in addition to the user input, we also provide the list of tools and what they can do as part of the input. And then, based on the output of LLM, we will decide what we want to use. So in this case, over here, LLM will tell us if the content, if it's just text or if it's a tool use. And if it's a tool use, it should provide us with the actual tool and the input to the tool. So pretty straightforward. And here we are just again executing the tool and giving the answer to LLM. It is a bit more code, but it's just some boilerplate code which you just need to write basically once and then be done with it. And then we have this chat loop where we'll just ask us for input and we will give the output to. It will give us hopefully us the answer through the use of the tools. So let's see our tools in action. So we will start first with just a bash tool. So we can ask it to, let's say, list all the files in the directory. And let's see what it will come up with. Okay, so we decided to run ls, which sounds about right, and gave us the list of files. Okay, looks good. So let's now try something more complicated with our multi-servers setup, where we, just as a reminder, we have access to file system. We can do the web search, we can fetch pages, and we can also have access to bash tools. Okay, looks like some tool doesn't want to cooperate with us. Okay, let's see. Let's try it one more time. Okay, I think one of the tools is not willing to cooperate. Let's remove. I think it was Brave Search. Let's actually quickly. Okay, for some reason I can't edit the JSON. Interesting. All right. So, but yeah, well, I won't spend time debugging it now. But yeah, basically, it would be the same, the same behavior as we've seen before, but it is much more involved because now we can just easily connect any servers we want, any servers defined by the community, by the Anthropic, and so on. And actually, recently, I think yesterday, OpenAI also announced that they will be adopting the MCP protocol for ChatGPT models as well. So basically, you will be able to use the same tools you use with Claude, with OpenAI. Yeah. So with that, let's actually go to the next level. Next stage is multi-agent collaboration. So we had our tools defined just as essentially Python code or NPX code or whatever. But you can imagine those tools being also agents on their own, right? So you could have a sort of like supervisor agent, which has as its tools another agents. And then those agents can have other agents and so on. So it's sort of like a hierarchy of agents, potentially, which can either call each other for help, which can delegate tasks to each other, and so on. And let's now see how we can actually implement these as well. Let's see, multi-agent. All right, so for this, I will be adding one more layer of abstraction, namely length graph from length chain. We still will be using Cloudy as our model as LLM model. And we will have the same, pretty much the same tools as we used before. We have shell tool, we have Brave search, file management, but we will also add one more tool, essentially human tool, which will allow LLM to ask questions back to us. So it will be able to ask for any requirements, any clarifications, and so on. The reason I'm using length graph here is just because it is easier to basically, length graph encapsulates a lot of boilerplate code again, but in general, you can define all of these multi-agent interactions as quite easily through structured inputs and outputs. It's just length graph nicely hides all of these boilerplate from us. So I will be having, in this case, 3 sort of team members, virtual team members: front-end developer, back-end developer, and DevOps engineer. Hopefully, they will be able to work together. We'll see. And I have a supervisor who will be supervising them as they work towards the same goal, right? So you can think about it as a product manager, for example, right? So with length graph, it is pretty easy to define your agents with just a prompt. All you need is prompt. In this case, I'm defining the prompt for the supervisor. I'm telling it that it has those team members, right? And it can also ask for the clarification from the user. Then when it's done, it needs to tell us finish, sort of the keyword finish, and then we are done. And for available tools, I will be given in all the tools again, and then we have basically this our supervisor node over here, which is just the LLM with structured output, and that's pretty much it. And the same goes with for our virtual developers, virtual engineers. I'm specializing them specifically on front-end or back-end, but in general, of course, you don't need to do that. Although it does help to sort of focus them on specific tasks, on specific tools, and so on. So in this case, again, as I mentioned, I have front-end developer, I have back-end developer, and I have DevOps engineer, and they are instructed with pretty much the same prompt. Just help each other, ask for any clarifications from the user if you want, and you can use those tools which I've just shown before. And in the end, we compile all of those agents in the single graph, where we have the start node as supervisor, and then that supervisor can call front-end, back-end, and DevOps engineer. So in this case, all of the interactions will go through the supervisor. But of course, you can imagine each agent talking with each other separately. So you could potentially also have connections directly between those nodes, for example. So you would get pretty elaborate graph. But in this case, just for the simplicity, all of the interactions will go through supervisor. And for the task, I will be asking the LLM or the multi-agent system to create a website for the conference. I want a few pages. Right, pretty basic website. Front-end needs to be in React, back-end in Fast API. Use a Postgres, pretty broad, but still, pretty, I would say, clear to some extent requirements. Right. So let's see what our agents will be able to work out from that. And again, hopefully the internet connection will allow us to do that. So as you can see, it first started with supervisor as expected, and then it decided to call the front-end developer. Which I guess makes sense for that task. Then front-end developer decided to ask some clarifications. So that's a lot of questions. And as a good product manager, I will tell it to do it yourself. Because I don't want to bother answering all those questions. I need to be on the meetings. So yeah, with that, it decided to execute some commands. So it decided to use, I'm not sure how to pronounce it, Vite package to create a conference frontend package. Basically, it will take some time because npm install usually takes quite a lot of time. Yeah, but we should be able to see already something happening in our file system. Where's the refresh button? Yeah, it's using Anthropic, yeah. So we already have the directory, we already have some code over here, some node modules are already installed, so we should be able to see, yeah, we already have some source code for our hopefully working website. Yeah. And it usually does take some time because they would need to go back and forth. Hopefully soon the backend engineer also will kick in and ask us something, or maybe not. But yeah, basically, you can follow all the progress through the output. It will just create some files and do all the typical boilerplate coding for us. Now we won't be, I guess, waiting for it to finish because we are kind of short on time. So, but yeah, again, the code is open source. You can find it on the GitHub repository I linked before, and you can play around with it at your own time. So let me go back to the presentation. Well, you can try. You can also ask it to tell it that you give it a lot of money and whatnot, so maybe it will work faster. We'll see. But yeah, basically, these all can be done manually, of course. But there is, of course, a better way. You don't need to spend all the time defining that for you yourself. And this is where we as encoder come in. So basically, we are coding assistant. We have a lot of engines which are integrated into your IDE. Just a, I guess, quick demo for that. Hopefully, again, it will work live. Let's see. Where is my? I don't want me to show anything here. Okay, let me do it like this. Where is my VS Code? Oh, sorry. Let's see. Where is VS Code? Okay. There is our VS Code. Let me move it to this screen, or maybe not. What is going on? Yeah, that's true. Thank you. All right, now it should work. Hey, finally. Let's see. Where is our VS Code? It's still on my screen over here. All right. So yeah, we are integrated nicely into your existing IDE. You don't need to switch us like with Cursor or Windsurf, whatever. And we can do pretty typical task of your everyday life. We can reference actually specific ticket in Jira. Let me actually zoom in a bit here. So I have this ticket for which asks us to add the documentation, and we can ask it to actually solve it, create a branch called Voxed, and commit the changes. Right. So basically, your typical small task for 5 minutes, right? And let's see, we will turn the coding agent on, and let's see if it will be able to fix that for us. And yeah, indeed, the ticket itself from the Jira, it asks us to add some doc strings to that file. So basically, decided first to create a branch, check it out, and let's actually open the terminal. Open the terminal. Yep. All right. So see, it's added, committed. I think it is done. So let's see. We are indeed should be on the branch Voxed as expected, and we should see our commit, which just happened recently. Yeah, there it is. So basically, in a matter of minutes, you fix this small ticket. But of course, you can do much more than just adding documentation. You can ask it to solve pretty much anything. Now, with that, let's actually get back to the presentation and talk about what's next for us, for the developers, with all those tools coming in to the market, and with all the headlines that our developers will soon be replaced. And you can think about it. And yeah, it's time for some memes, of course. And you can, of course, think about in two ways, right? You can think about as some way to get free from all the requirements and product managers, whatnot, and maybe chase your life dream of getting a goose farmer. But yeah, but at the same time, there is still a lot of there still will be a lot of jobs in manual labor. Of course, somebody will need to train LLMs to do what they need to learn. Somebody would need to write the code. Okay, but then jokes aside. So in our view, in the view of our company and in my personal view, I think we indeed there will be indeed some changes to the way we work, right, in the next couple of years. But I think it will be more of change in the paradigm from us being actual developers to more of us being the managers of virtual developers, virtual engineers, and that comes with both positive and negative aspect there, because of course if you are a senior person, you're already kind of doing managerial work, you're reviewing code of your junior developers probably, right? You are essentially just telling them what to do, and that you will get the same juniors, but they will work faster, hopefully, and maybe even better. But at the same time, if we sort of get rid of the juniors, we won't get new seniors, because seniors need to come from juniors. So there is a sort of this negative aspect which we as a community, I guess, need to think about. But that's, I guess, a problem for another day. And with that, a few QR codes over here. On the left, you can get a link to our website. On the right, you can get my contact details if you want to connect and if you have any questions. And I think we have 1 minute till the coffee break. So I will be happy to answer any of your questions. Yeah. Okay, so for the pricing, we have 3 subscription plans. One is free, it is limited on the usage, and we have business plan, which is $19 per user per month, so 19, and we have enterprise, which is $39 per user per month. So pretty much the same, standard pricing as you would see in any other competitor. Yeah. Okay. Yeah, sure. Let's see where it is.
So with the server, the MCP server that you can run, is there a one that has like the capability to, I mean, they can now navigate the file system, to read the file system, so you can ask questions about the project without going online and use the local mode?
So, are you talking about the encoder specifically or in general?
In general.
Yeah. So, well, I mean, you can of course use local models, right, with the MCP servers as well. They won't be as capable as Claude or OpenAI, of course, because well, you can't run the similar size model locally, probably, most likely. But still, of course, you can use local LLM to ask it any simple questions, to ask it to look through the files and give you some summary or whatnot. But still, for a larger project, for a larger repository, it is much more productive to use something more larger.
I'm asking because it will be cheaper maybe for large project, because if the context is big, it will cost a lot per request. So you would want to use a local variant for this thing. So you can ask away how much you like.
Yeah, well, that's a good point, but again, it's sort of like a balance between cost and quality, right? So you can't run large models on your local laptop, right? So even like latest MacBooks, they can run Llama 33B, but that's not good enough usually. But at the same time, the reason why you don't want to define all of these things yourself is because we, for example, we as encoder, we focus a lot on finding the best context. So it is also a balance between overfeeding the LLM with the context and also underfeeding, kinda. We need to find this sort of golden log, I guess, and it is quite a difficult problem. Yeah, and well, I think we are pretty good at that, and it's not coming from just me; it's coming from our users who switch to us. But of course, you can do the same, similar things manually. It just they will take more time, more effort, and, but it is always fun, of course.
This step of finding
Well,
The planning work.
yeah, yeah,
Okay.
to some extent, yeah. Okay. All right, so I guess no more questions. You are free to go back get coffee.